Good morning, students. This is going to be our last math lesson for this week, and then we'll have Christmas break after this. This is going to be about triangular properties. So it's page 114 through 116. So what we're dealing with today is the idea of what are the different ways that we categorize triangles. You should be familiar with this because I think you were taught this in grade 6, but this is going to be mostly review. So I expect you to be able to go quickly. This is going to be a combination of everything that we've been working on for the last week. So you're going to need to have a protractor. You're going to need to probably have a ruler, and you should also have a nice pencil. I don't know if you'll necessarily need, what's that thing called? The square, set square. But I think you need protractor, you need ruler. Okay, so what are the three basic ideas that we have of triangles? So triangles must have three sides and therefore must have three vertices. These little three dots, by the way, if you didn't know this mathematically, that means therefore. Um, so every triangle always has three sides and always has three vertices. The internal angles of a triangle always add up to 180 degrees. That's what you learned from yesterday. And also, seems obvious, but it's good to mention. Triangles must be made up of only straight lines. Okay, so these are general basic rules of every single triangle. You know these rules from living your life, but it's good for us to review because we're going to talk about different ways that we categorize triangles. So the way we categorize triangles can be separated into two different ways. So either we can look at measurement of angles or we can look at measurement of sides, and they're going to cause us to have different names. Now there can be overlap with some of these, where maybe an equilateral triangle is always going to be an acute triangle. Or obtuse triangles may sometimes be scalene or isosceles and never equilateral. What we want to get the idea though is these are the three different ways that we categorize, or the two different ways we categorize triangles, and these are the three different categories that they would be in. So a right triangle is always a triangle that has a 90-degree corner or angle. Okay, so every single right triangle will always have 90 degrees. That is the fundamental rule of a 90-degree angle, or of a right triangle, sorry. An acute triangle is a little bit different. It says acute because every single angle within the triangle is an acute angle. So that means you don't have any angles that are more than 90 degrees or equal to 90 degrees. So you could have an angle that's 89.999 um, degrees, and the other two could be maybe 45 and 44 point something something something. At the end of the day, it's still an acute triangle. If it does not have a right triangle or right angle in it, and it does not have an obtuse angle in it, therefore it's an acute triangle. Okay. Now an obtuse triangle is visually different, and the basic rule of an obtuse triangle is it has one angle that is an obtuse angle. Okay, so these are the ways that we measure triangles, and you're probably more familiar with these three. These other three are a little bit odd, and I know you've covered this before, but we're going to review them. This is how you categorize triangles based off of side length. Okay, so I put these little ticky marks here, and what this indicates is one ticky mark means that these are all the same length. Okay, now I know it's not perfect, my drawings are not amazing, but this is the way that it's the meaning. So equilateral means every single length of sides is the same for this triangle. Isosceles means that there are a pair that are the same and then one that's different. And then scalene is three different lengths for every single side. So, and to sort of demonstrate that, and one of the ways you can do that is visually, we can, if we're talking about maybe this one, an acute triangle, we can demonstrate an acute angle by one dash, but also in some situations, we can just put this little mark and this little mark. And what that actually is saying in some contexts is these are the exact same angles. So if I have a triangle, so say I look at this triangle right here, and I'm demonstrating that it's an acute triangle without asking the person that's looking at this work to like actually measure it, I can just demonstrate that with this symbol. So this tells me that these angles are all the exact same. Okay, that's a way that you can do that. And I've shown that these are three different angles, and you can actually demonstrate it in three different ways. So this is one, this was two, this is three. That means that every single one of these angles is different from each other. We can also do the exact same thing with measurement of sides. So we can do one dash, and that means that these two lengths are the same. I know they're not perfect, but work with me here. This is a two dash, and there's no other two dashes, and this is a three dash. Okay. Now, when we do this, whenever we put these dashes, what we mean is they're always contained in one shape. So if I have a square here, I do a one dash for every single one of these. If I were to do a shape right beside that and do a one dash as well, I am not saying that these are not the same length, even if they're beside each other. Every single marking system, so dashes or angles, is contained to the one shape that you're dealing with. Okay, so try not to overlap. Um, but yeah, that's pretty much what we have for today. So today you'll find that there'll be a review of this, but also you're going to be using a bunch of other skills. So like you're going to construct triangles with specific angles, and you're going to be doing that sort of work. So you can think of this as kind of like a review for the last week and sort of making sure that you're on the right track. Okay. If you have any questions, please stop by in the drop in meeting and I will be happy to answer anything you have. Have a great day.